Talk about objects and classes. So I'm excited for this lecture. I don't know about y'all, but this is a lecture where a lot of the things that I've been foreshadowing for the last 2 weeks, we're going to address them here. All the public versus private, static, non-static, objects, classes, all that stuff. We're going to get to it all today. Now, today's lecture is going to be fast-paced. There's a lot. If you might get overwhelmed at today's lecture, just to be honest. But on Wednesday and Friday, we're mostly going to be reinforcing all the concepts. So it will be a lot of new stuff today, but I want to get everything out there today, and then we can spend the rest of the week reinforcing and figuring out what the hell happened on Monday. So let's talk about it. So we saw this example last week, a week ago. We saw this ArrayList example. I just have a small snippet of the code right here, not the full thing. But we saw our first case where we put an object on the heap. Let's talk about what that meant. So when we used the new keyword, that meant we were creating a new object of a specific type. And to do that, we were calling the constructor of the class defining that object. So here we created a new ArrayList. We called a method named ArrayList, and that created an object on the heap of type ArrayList, and then returned a reference to that new ArrayList that we created. So the ArrayList was stored on the heap, and then in our variables of type ArrayList, those variables only store a reference to the object on the heap, which is like a roadmap. It's instructions on how we can find this object in memory. Where do we go in memory to find that object that we created? And then to use that reference, we're not interested in references pretty much ever. We use the dot operator to access the object that it's referring to. So we have this reference, OX200 in this case. Dot means take me to your object. Follow that roadmap, follow those directions, find in memory where that object is, and then do something with it. In this case, add elements to that object. Classes are used to create objects. This is the primary purpose of classes. We've been using classes kind of in a different way so far this semester, just because all code in Java has to be contained in a class. But now we're going to see the true power of classes. They're used as templates to create objects. A class tells Java, this is what my objects of this type should look like, and the class defines a brand new type in Java. So the ArrayList class defines the ArrayList type, and then we can create objects of type ArrayList and then store references to those objects in our code. I'm going to be using some of the code from the actual ArrayList class in Java. I'm going to significantly reduce the code. I'm going to show just a very, very small portion of the ArrayList class in the slides. But if you do want to look at the full code, either Control-click or if you're on a Mac, Command-click on ArrayList. So if I hold Command on my Mac and click ArrayList in IntelliJ, it's going to take me to the code that defines an ArrayList. It'll take me to the ArrayList class. And you can look at all of the code in all its glory there. There's a lot of it. It's over 1,000 lines of code to define an ArrayList. But you can check out the full code there. I'm showing a very, very small portion of it. And it's in a package, Java util, class named ArrayList. So when we import, Java util ArrayList. So I said when we say new, we're calling the constructor of that class, which is going to create an object of that type. So let's define a constructor in the ArrayList. We have a public method named ArrayList. Constructors are special methods that have the exact name of the class that they're in. We're in an ArrayList class, so we have a method exactly named ArrayList. It's not static. Most of the methods we're going to see from here on out for the rest of the semester are going to not be static. And it doesn't have a return type, at least not an explicit one. So the constructor is going to return a reference to the object that was created. That's implied by it being a constructor, and it's a constructor because it shares the name of the class that it's in. So we don't have to specify the return type. It would be redundant. So this ArrayList method is going to be the constructor because we followed all the rules of a constructor, no return type, not static, matches the name of the class. We got ourselves a constructor. So that's the method that's called new and then ArrayList. This is actually calling a method named ArrayList, which we call the constructor of this class, or a constructor of this class. Constructors can be overloaded. I didn't know where to put this, so I kind of jammed it in right here. Constructors can be overloaded, and in fact, all methods can be overloaded. What that means is we can have multiple methods with the same exact name as long as they have different parameter lists. So the ArrayList has a second constructor, which actually takes a parameter, it takes a collection of values, and then it'll initialize your ArrayList with those values. So this constructor and all the code is removed. You can feel free to look at it in IntelliJ if you'd like. But this second constructor takes a collection of values, and if you want to create a new ArrayList and initialize it to some values, this arrays, which has to be imported as list, and then give it a comma-separated list of values, and it'll initialize your ArrayList to those values. I've been talking about this in office hours and students asking questions after lecture. I've been giving this tip a lot. When you're testing your average method and you're creating a bunch of ArrayLists, it gets tedious to create an empty ArrayList and then call .add. It's a bunch of code, it's a bunch of clutter and everything. If you do this, it can really clean up your tests when you can create your ArrayList and populate it in a single line by using this second constructor that takes that collection, those values, and adds them all to your ArrayList. And ArrayList actually has a third overloaded constructor that sets the initial size, something we're not going to be concerned with in 1.16, something we won't use. Classes, or rather objects, have state and behavior. An object is basically a container that contains state and behavior. Our state is variables, which we'll call instance variables when they're part of an object, and behavior, which are all the non-static methods of the object. So the variables, what are going to be the instance variables, these are any variables that are declared outside of all the methods in your class. So whenever you have variables declared out here in kind of this void out here, not contained in any method, inside the method, those variables are local variables. They'll get put inside the stack frame for calls of that method. Outside of all the methods, they become instance variables and become part of any object created of that type. So every ArrayList you create has these two variables, an array of objects called element data and an int containing the size of that ArrayList. The ArrayList also has behavior. So we define some non-static methods, and that's going to be the behavior of the objects. These are all the methods that we can call on an object of this type. If we have an ArrayList and we call .size, it's straight up going to return the size of that ArrayList. In your constructor, that's where you're going to initialize the state of the object. So whenever you create a new object, it's created through a constructor call. And in the constructor, the code for the constructor, that's where you want to initialize all these values. Whatever makes sense for your application to initialize those values to, that's what you'll initialize them to. So if the empty ArrayList constructor is called, element data, which is the underlying array that stores all the values. So an ArrayList is I don't want to get lost in the details here, but an ArrayList is a data structure that actually just wraps around a regular array, a plain array, and then it adds a whole bunch of functionality on top of it and hides the fact that you're actually just using an array by adding all kinds of functionality, a lot of behavior, a lot of methods on top of that. So it makes it easier to work with an array in Java by using this class. If the empty constructor is called, that underlying array is just set to a default empty array that's stored as a constant in this class, a static constant. I'll talk about that a little bit more in a minute. And I removed the code here, but if you call the second constructor, it will add all the elements you give it to element data and also set the size equal to the size, the number of elements that you added into it. It'll initialize those values to whatever they should be for that particular object that's being created. So that's the constructor's job, is to initialize the state of an object. And then don't get bogged down on the code too much. I'll explain it very briefly, but it's not important to fully understand the code that we're seeing here. There's a few things here that we haven't talked about, and a couple things that we won't talk about ever, like typecasting. We're not going to do typecasting in 1.16. But we have more behavior just by having more non-static methods in our class. These are the methods that can be called on an object of type ArrayList. And notice that the add method is overloaded. There are two add methods, one public and one private, one that just takes an element to add, and one that takes three parameters that does a bit more, where there's a bit more going on. This is common to have what we call a private helper method. But I want to talk about that right now, I guess. Let me briefly explain what this is doing. I don't want to get lost in the details of ArrayList specifically. This is just my example of a first class. But an array can never change size. So an ArrayList just has an array as its instance variable, but this can never change size. So if we ever run out of room when we're trying to add an element into this array, what an ArrayList does, it calls the grow method, which isn't in my slides. It will actually create a new array of double the size, copy all the values over, and delete the old array, and then use the new array. So it's giving you the illusion that you have an array that can adjust its size by having some extra functionality built in to the ArrayList. And then to us, we just call add and don't think about it, which is nice. I don't want to have to think about that. But internally, this code is doing quite a bit of work for us. We see the keyword this all over the code. This, I'll talk about the keyword this a bit more when we get to the memory diagram. But this, the keyword, is going to store a reference to what I'll call the calling object. Whatever object called the method, this is going to be a reference to that object. So when you call r1.size, this is going to be whatever reference is stored in r1. Whatever reference is stored in the variable through which you called the method. So this is a reference to that calling object, except in the constructor, technically it still is, but in the constructor it's a reference to the object that's being created. So this, it's a special keyword, stores a reference to the object that called the method. We're seeing public and private all over the place. We've talked about this. I briefly mentioned it in previous lectures, but let's talk about it in a little bit more depth. So private, let me start with public. Public means anybody can call the method, anyone can access the variable. So we have some public methods here. Our constructors, we want these to be public. Everybody can create new array lists from any code, anywhere. You just import ArrayList and call the constructor, call new ArrayList. Everybody has access to that method. The private methods, nobody has access to except the code contained within the ArrayList class itself. So nobody else has access to private variables and private behavior, private methods. This is, in general, called encapsulation. This is a word I haven't used much in the past, but I had a TA, Leo, say he just went on a job interview, I think over winter break, and one of his questions during the interview was, explain encapsulation to me. And he's like, what's that? Nobody uses that word around here. So I want to make sure I get this in slides more often, just so when you get that in a job interview, you don't have to look like a fool like he did. He did well on the question. He's just like, what's encapsulation? And the person's like, oh, it's like this idea of hiding data. And he was able to take that and run with it and explain a whole bunch of, basically explain what encapsulation was. But there's a bit of vocab. I got to make sure I get this in my slides. So encapsulation is the idea that we're hiding details. We're hiding details from people to make their lives simpler. So any private variables, anything that we don't need other people to know about, we make it private. And all these private variables, they're hidden. The private method is hidden. So this add method, for example, which I think I'd talk about in the next slide. This add method that takes 3 parameters, that does this resizing, we never have to care about this method. We never have to even know that it exists. You go your whole career without knowing this method exists. After today, you can be like, I forgot that there's a second method, an overloaded add method in Java's ArrayList. And that's perfectly fine. It's a private method. These details can be hidden from us, and we don't have to care. The fact that an ArrayList actually uses an array of, a plain old array of objects, we don't have to care about. The fact that it has an int that tracks the size, we don't have to care about that either. We don't have to care about any of this stuff. And the writers of this code said, we're making those private. You don't have to care about them. You don't even have access to them. We're not even going to let you look at that stuff. We're going to make them private because you don't have to care about these details. And then all the public methods are what we call the public API, the public-facing API of this class. API, Application Programming Interface. In short, it's how 2 pieces of code will interact with each other. So our code is going to call these public methods to access the API of an ArrayList and actually do things with an ArrayList. These are the methods we care about, the public methods. We care about these constructors. We'll use both these constructors. In your homework, you'll probably shift to this one if you haven't already to keep your tests a lot cleaner. We want to know the size of an array. We want to be able to get values out of an array. We want to be able to add values into an array. Those are the things we want to do. And anything private here, through encapsulation, we're saying we don't care about those things. They're internal details to how an ArrayList works. We don't have to care how an ArrayList works in order to use an ArrayList. It can help to know, and in CSE 250, you'll learn all about this doubling in a lot more detail than I just gave. I just gave the TLDR of it. But to use code, you don't have to care about the private details through the power of encapsulation. In fact, when you have an ArrayList and you do in IntelliJ ArrayList dot, and it gives you a list of everything you can do with that ArrayList, it won't even show you the private methods. Because you can't call them anyway, so why would it? But the details are completely hidden. You just get the public API, and you don't care what happens after that. As long as that element that you called add on actually gets added, who cares how it did it? That's encapsulation. And finally, static. We talked about static and non-static. I've been talking about non-static methods today. So static methods belong to the class. Non-static methods belong to objects of that type defined by the class. So static belongs to the class. Non-static belongs to objects. So when you say new ArrayList and you get a reference to an object on the heap, when you get a reference to an ArrayList, you can call all the non-static stuff. It has these non-static variables and all these, well, not really the constructors, and all these non-static methods. Anything that's static is part of the class and can be accessed through the class itself. If I say ArrayList dot, I can access all of the static stuff. So when you're testing your code for task 1, you're saying problem set, the actual name of the class, dot average, because you're accessing the static method through the class. After task 1, pretty much everything's going to be objects from here on out. And you'll say, give me a new ArrayList, and then ArrayList dot to access the non-static functionality of the class. Sorry, I wanted to mention. And we've seen one constant before, the epsilon variable. We've seen pretty much just like this, except it wasn't static. Was it static? I forget. But this is a class variable. It's private, and it's a constant. So whenever you create a new ArrayList, it's always going to be initialized to an empty ArrayList, an empty array. The element data is going to be set to an empty array. Whenever I say method from here on out, I mean a non-static method. If I mean a static method, static is kind of the special case. I'll specify static method. If I just say method, I mean a non-static method. For the first 2 weeks of this course, before we know about objects and stuff, pretty much everything's static, just so we don't have to create objects to be able to use our code. Just makes it easier for the first 2 weeks, but now that we know about objects, we're going to be using OOP, object-oriented programming, for the rest of the semester. So we're pretty much done with the keyword static for the most part, except the main method. Main method, when your program starts, there's no objects in the heap yet, so main has to be static. Some classes have nothing but static methods and static variables. The math class, for example, is only made to be static. And when I talked about the constructor, we saw public constructors, but that's not a requirement for a constructor. You can actually have a private constructor. The math constructor is private. It never makes sense to say new math. We're just going to say math.abs, math.e, math.py. We're going to access its state and behavior through the class. So the math class is just a bunch of static variables and static methods. And I don't know why, but degrees to radians and radians to degrees, somebody decided to make them private. I think it would make more sense to make them public, right? So we can access those constants instead of having to multiply and divide by 180 in pi. But those ones are private for what it's worth, so I left it on the slide. And the one math method we saw, ABS, is a static method in the math class. So we said math.abs. I think I just said that, didn't I? In private, you cannot say new math because it's private. You can't create a math object because it wouldn't make sense. There's no non-static anything, so it doesn't make sense. Okay. So that's a lot. Give me your questions. Yep.
I spotted a question mark in both this one and the math one.
Good question.
What is that about?
Yeah, what is that about? Okay. So I kind of purposely didn't mention this one, but let's talk about it. So let's start up here. So the type parameter e. So whenever you create a new array list and you say, give me a new array list of integer, e is going to be replaced by integer in all instances in this. So it'll be integer, 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 integer. These will all be replaced with integer. I might as well talk about typecasting while I'm here. This means this is going to be of type object, and this in parentheses and a type means force this to be of type E. So it's changing from object to E. That's not something we're going to do in 1.16 if we can avoid it. I'm pretty sure we can avoid it, but there might be some library we use where we have to do that. But that's changing this to a value of type E. The question mark means anything that extends E. So E being of type integer is a bad example for this. I'm just going to make stuff up. So integer, say there's a type called number that we haven't talked about any of this yet, have we? It means it's something that's close enough to being an integer that it's fine. So if I have some object of type number and it can be used as an integer, that means allow any integer, but also things that are close enough to being integers that we'll call it cool. That's what that question mark means there. This is in our code that we write for this class. We won't need to know the syntax throughout the whole semester. But it is interesting it's there. I didn't even think of that when I put this on the slide. Question mark extends E is something brand new. In 3 weeks, we'll be in a spot where I could give a better explanation of that. It involves inheritance, is the shorter answer. Any other questions on this? No questions in chat? Yeah. If it's not static, it doesn't mean it's what? Dynamically loaded? I might not be ready to answer that question. Dynamically loaded, it does mean that you can only access the non-static stuff through objects of that type. I'm not familiar enough of exactly like how the class loader loads things in, if it loads that in later or not. I would think that it loaded in all right away, but I'm not 100% sure. All right. Everyone ready to move on to the next step? Let's create our own class. So, and by the way, I don't expect this lecture to be able to get through all these slides today, but it will spill over to Wednesday. It did in the previous lecture, which I almost knew for a certainty was gonna. But some of it's planned to spill into the next lecture. So we're going to create a player class, which is going to define a player type and allow us to create objects of type player. Player is going to have some state, max hit points, current hit points, and name. And then next lecture, that's what we'll do this lecture. And then next lecture, we're going to add attack power and some behavior to be able to have players fight each other and take damage, which we'll not even attempt to do today. And there it is. There's my code. So here's a player class. Here's the start of it. We're going to add to it as we go. But here's the player class. It's going to have the state of the three variables that I mentioned. We have HP, max HP, where HP is going to be our current HP, max HP, and name. And every object of type player is going to have these three instance variables. So whenever we create a new player, each player is going to have its own copy of these three variables. Then we're going to create a constructor. The name has to exactly match the name of the class. And when we design a constructor, we want to think about what makes sense for a user of this class to initialize for each object that's created. And for this example, I chose name and max HP. So whenever somebody creates a new player, I want that player to have a different name, and they might have different max HP depending on their character's class or whatever. They might have a different max HP when they're created. But it didn't make sense to me to initialize HP in the constructor. I'm going to say any player that's created is going to be created at full health. It just makes sense to me. Instead of adding a third constructor parameter for HP and then making people type in max HP and HP, which are almost always going to be the same, I would suspect, for any application of this. Instead, they just have to say max HP, and then we're going to set the HP equal to the max HP when they initially start. So thinking about what your constructor parameters are based on what should be initialized of the state variables differently between different objects. We're not going to do it in this example, but I want to at least mention this. You can initialize variables right when you declare the variables outside of any methods. So if there's any instance variable that you want to initialize to the same value for every single object of that type, you can just create it right here. So if I decide that I want every single player ever to start with 10 HP, I can initialize it outside of the constructor. And then the constructor is just for things that are initialized that are going to be different between each object of this type, between each player. Very common, we will do this in this class. In Java, your instance variables should be private in almost all cases, unless you have an extremely good reason to not have it private. Or as we'll see at some point, we can have them be protected. They should not be public ever. So our variables in Java are going to be private, our instance variables, so nobody can access our variables of our objects. But wait, how does anybody use our state? And we've seen this in the ArrayList class. So we kind of saw the answer. The ArrayList has private variables. There's no public state available in the ArrayList, and with most objects in Java. To access them, we're going to use getters and setters. Woo! If you've ever coded in Java before, you've seen these, and they add, I don't know. I have a love-hate relationship with getters and setters. It's more hate than love, though. But we have private variables, and then to access that state from outside the class, we expose public getters and setters. So to set to use max HP, you're going to call get max HP, which just returns max HP in this case, and set max HP, which takes in a parameter and sets the instance variable equal to that value that it was given. These are getters and setters, and the names are usually get variable name, set variable name. So getters and setters, these are public, and this is how people outside of the class interact with our code. This is just standard in Java. If you're at all familiar, or watch old videos or whatever of this course in Scala, 116 in Scala, I never talked about getters and setters and private instance variables. It's because Scala has a better answer to this problem that we're about to discuss in a little bit more detail. Scala has an actual answer to this problem other than the way Java does it. If you do classes in Python, Python has a better answer to this, better in my opinion, I should say, solution to this problem. But let's see what the problem is and why we're using getters and setters to solve it in Java. So why would we ever do this? Why not just let people access our variables directly? Well, the answer is if we want to control those variables in any way. If we give direct access to our variables, we have no control over the values that can be set in those variables. So if we give full control to our variables, we can't do something like this. So say we want to say, okay, you can set the HP of a character, but you can't go above their max HP. We can write in the setter, add a check, and sanitize the input here to say if that HP is greater than the max HP, cap it out at the max HP. Don't let somebody go over health. If we give direct access to our state variable, or our instance variable, to everyone and by making it public, and I have a max HP of 10, what's stopping someone from saying HP equals 1,000? Give me basically an immortal character, depending on the game and everything, or max HP or HP equals 1 billion. We can't do anything. Once we give control of our variables to everyone, and people start writing code that accesses our variables and sets our variables directly, we no longer have this option. But if we have these private and use getters and setters, even when we don't need them, we don't have any checks on max HP, and we can also do formatting for the getters. If we want to store data in one format but return it to users in a different format and hide the internal details through encapsulation, we can't do that if we give direct access to our variables. So if we give direct access to our variable, I lost that sentence. We have private variables and then public getters and setters. If sometime down the road, even if I'm not using them, I want to add some checks to max HP, or I want to add some formatting, maybe get HP instead of returning the raw HP, I want to return the percentage of max HP that we have, I can make that change now. Because everybody who accesses HP and max HP, they have to call the getters because they can't access the private variable directly. So now I can add my stuff. Even if I'm not using it right away, I can add those checks in the future. Maybe I want to do some formatting with the names. I have that option now. I have control over my own code. As soon as I have public instance variables, I lose that control. And now people can break my code and blame me when they were abusing their direct access to my instance variables. So that's why we'll do that. We'll do that throughout the semester. And now that we have getters and setters, we're going to change the constructor. In the constructor, we're setting our variables directly. But it's common practice, it's better practice to call your setters. So in my setter, if I want to have some checks to make sure the values are sanitized and sane, I want those checks when somebody calls the setter and when somebody calls the constructor. So instead of duplicating this code twice, having it here and then having it again in the constructor, I'm just going to call my setter and let my setter code handle it. I'm just going to write my checks once in the setter, call the setter in the constructor. This will apply in your homework when you're writing the ratings. Yeah, rating. I had it called review a while ago. Rating is what I sell on. When you create the rating class, and it's going to store a rating from an integer 1 to 5, and if somebody tries to go lower than 1 or higher than 5, you want to sanitize that input, and we're going to set it to -1 to indicate an error. That can happen on the setter and in the constructor. If your constructor is just calling the setter, you only have to write that code to make the check one time. So we want to reduce our code a bit by that. And classes define new types. Once we have this class, this player class, we have a brand new type in Java. We know that our Java is strongly typed. Every variable has to have a type. Every parameter to a method has to have a type. The return value of methods have to have a type. Our data structures have to have a type parameter, the type that they're going to store. Now that we have this player class defined, we have a type called player. We can write methods that take players as parameters. We can write methods that return players. We can have an array list of players. We can have a map of player to integer. And we can have local variables of type player. We just defined a brand new type in Java. And every type in Java that we have, aside from the primitives, are defined using a class. Aside from the primitives, there's a one-to-one relation, types and classes. Not entirely true, is it? I guess that falls apart a little bit when we introduce interfaces, but either a class or an interface or an abstract class, technically. Any questions on this? This is a lot of the classes and objects content. There's a lot all in one day. There have to be questions out there. Last lecture I asked a ton of questions, but I think I got a lot of the answers incorporated into this lecture. There are no questions. We could just sit here and digest this content a second. There was a lot there. What is an object? Okay, hold on. No, I can't. No, I have a better answer for that. Because I don't think I fully really did explain what an object is. So an object is whenever we say new and then a type and call the constructor, we're creating an object. Whenever we see something on the heap, it is an object. Objects go on the heap. Nothing else goes on the heap except objects. So whenever we created a new array list, we had an object, an array list object, which had all of the state and behavior from the array list class. Anything non-static in the array list class, an array list object has. And we created that object by saying new array list and creating an object on the heap. So a class defines a type, and then we can have objects of that type. When we say new player, which we're going to see in the next code example, when we say new player, we're creating an object of type player. Before we say new player, we have a class, a player class, but we don't have any objects of type player. And objects, in short, are the things that we care about. It's called object-oriented programming. It's not class-oriented programming. Objects are the things that are going to actually do the things in our code. It's a weird sentence, I guess. But you've never cared about the ArrayList class, but you care about creating array lists, stuffing them with data, and actually using ArrayList objects. You've never used an ArrayList class, but you use the class to create ArrayList objects by saying new ArrayList. And objects are the things that really do the things. Everything that's non-static has to be accessed through an object. This keyword, I think that one will be better in the memory diagram. I'll get the start of it on here at least, so we can stare at that while I'm answering questions. This is a reference to the calling object. So when we have method calls here, when we call a method, whatever object called that method, this inside that method is going to be a reference to the object through which that method was called, or in the case of a constructor, it's going to be a reference to the object that's being created. Yeah.
Why are we using a player type?
Why are we using the player type? Wait, what was it?
Why are we substituting player?
Wait, sorry, I missed that again. Why are we using the player type instead of using the actual what? I'm not 100% sure I got you. So we have like the variables max HP, HP, and name. Why not use those directly? Is that what you're saying? I think you have a good question. My brain is just like, I can't do it right now. So why are we using the player class instead of using the variable directly that we need? So like here, we're going to have a variable of type player and create a new player object. We can't do that if we don't define the player class. If we don't have the player class, we can't create player objects. Hopefully I'll get it when we get to some more memory diagram stuff. Maybe it'll make more sense. Like why are we creating the player class at all? The short answer is it's a lecture example. I just want to show how classes and objects work. Like this class, like the thought of it is it would go inside a video game and we'd be creating players and the players would be interacting with each other. But we don't have the full game. It's just an example of code that's small enough to fit on a slide, and it's here to show how objects and classes work. That's my short answer of why we're even doing the player class. But I'm doing it to show how classes and objects work. Well, we can talk after class too. Maybe I can give you a better answer. I lost my thing. Why are functions public and variables private? So we can have private methods as well. The short answer to that is encapsulation. Anything that shouldn't be accessed by everyone, in general, we'll make it private. So I don't want anybody accessing my variables directly. I want them accessing them through getters and setters. So I'm going to have public methods and hide my access to my variables directly. Because if somebody can access my variables directly, they might be able to break things. Like, for example, set name. I might want a max character limit on the name of a player, and I would add that in my setter. But if I give public access to this string, nothing's stopping somebody from going over that character limit. When you make a variable private, only the value can be publicly edited. When you make a private variable, only the value can be publicly edited. So when you make a private variable, nobody can access, like nobody can say .name. Oh, that's a bad example because they can there. Outside of this class, people can't say new player P1 equals new player, P1.name. They can't access that variable directly. They have to call either get name to access it or set name to set the name to a new value. So they can publicly edit it, but they have to do that through the set name method. And why is some code highlighted? I think the answer is because it's a slide for lecture. But let me make sure I understand what's going on. If my brain can do this today. Why is some code highlighted and some code not? Max HP or name? I was highlighting things, like I'm just using my mouse to highlight things sometimes. Maybe that's what you're seeing. In some slides, I'll put the box around it to highlight things. All right, let's get at least a start to this, and then I'll start at the beginning of the memory diagram next time. But just to see a little bit more of what we're talking about, when we create a new player, we'll